Hi, welcome back. And continuing in the same stream of what we were discussing earlier, which was mentions from antiquity all the way up to the Industrial Revolution, we are still focusing on the pre-Industrial Revolution period. One of the areas that I'm going to talk about now is timekeeping. And today, of course, we have the latest technology with quartz being used as a timekeeping mechanism because it has a specific vibrational frequency, which is extremely accurate to keep track of time. But when we go back several thousand years, didn't have these sophisticated mechanical systems or electronic watches, so they had to find other ways in which to track time. Water clocks were a very early, ingenious way in which you could track time. So the next few slides, you're going to see how they designed water clocks and their different mechanisms by which mechanical and non-mechanical systems by which they were able to track time. The very early water clock is something called a clepsydra. Clepsydra is a Greek terminology again, means to steal water. And as the term implies, it's a very simple timepiece. You have a large bowl of water into which you float another bowl which has a hole in it. The water fills that hole from the bottom, and it takes a predetermined amount of time for it to fill a complete bowl. And the predetermined amount of time is constant every time. So you're using that as a way to track how long it takes. So these clocks have been there for very long periods of time. The earliest evidence of a clepsydra or a water clock dates back to the 16th century BC in Babylon and Egypt. Some even claim that it was there in countries like India and other places, India and China in the 4th century BC as well. And this next example you can see is the Persian water clock. The same principle going back to the 3rd century BC, and you can clearly see this is an actual example of a retrieved water clock. You can see a large pot of water, and you can see within that is another bowl which has a hole in the center right there, and water comes in from the bottom and fills up. Now, where were they used? A good example of where these water clocks were used is in places like farming. Farming was one where you had irrigation, and there was always an issue with how much water did each farmer get, and when do you time these sluices where the water was released and when it was shut off. So in order to be equitable, there would be a assigned person who had a water clock that kept track of how long a particular farmer got water, and they used a water clock to track time. And it used to be something called kanat, or a well-like shaft that was used for water to flow through, and they used the water clock as a timing mechanism to turn the water on or turn the water off. There are other examples of water clock. The one that I just talked to you about was one where water fills up a bowl coming in from the bottom. The Egyptian water clock, on the other hand, was one where they took a pot, filled it with water, you had a predetermined shape to that, and then you have a hole in the bottom of the pot, and the water drains out of it. So this is an example of water draining out of a pot, very similar to a timekeeping mechanism where you use sand as a way to track time. Here you're using water as a way to track time. And this also goes back to about 1500 BC and has been found in several of the temples in Egypt. So these clocks are used by priests at night to find out the time it took for the water to come out, to track the time when they had to do the religious rites. And the typical case in those cases was just before sunrise, they had to start specific things in the temple, and being able to track the time before sunrise was possible by using a water clock. They were also used in daylight, but more often than not, because you couldn't track the sun at night, they used a water clock at night times to track time. Then there are other examples where you start getting a mixture of a water clock and a mechanical device to track time. The Greek water clock is a good example, as you can see in this figure here. This is a very ancient designed water clock which uses a fixed head of water, and what you're following here is the water drips down from this fixed head into a chamber which has a float on it. As the water fills up there, the float moves up. The float, as it moves up, has a rack and pinion system here, turning a gear, and that turns the clock needle around. So the way that goes is something like this, and this needle goes around as the water table rises. Now, the interesting thing in this approach is the fact that you have to have a constant head of water here, otherwise the pressure changes. In order to do that, what they do is they have a constant water supply with an overflow tube, so that the water is always full in this funnel, and so the head of water coming into the plunger here or the float region is always fixed. So this type of a water clock keeps track of time very accurately. And in Greece, it was used quite often in debates. And it is well known that Greek debaters used to always take a long time. And the way they were able to track time and make sure that a debater didn't spend too much time, for example, like Aristotle and others, was using a water clock to give them a specific amount of time to make their argument. So it was used in law courts, it was also used in political arenas to time speeches and so forth. And this again dates back to the 3rd century BC. The next slide here shows another example of a Greek water tower. This is in the center of town. They have a clepsydra at the center with the octagonal structure that also indicates the winds and the seasons. So this is a very nice tourist attraction even today. It doesn't have a working water clock at this time, but it was one way back when it was in working condition in 50 BC. The other water clock I would like to talk to you about is really a much more complicated water clock, which is a Chinese water clock. It was first developed around the 1st century AD, and later on a much more elaborate system was developed by Suzong in 1094. This type of a mechanism is a little bit more complex. It makes use of a number of things. It uses an escapement mechanism. It also has a mechanical process to transfer energy to a timekeeping element, and it also keeps track of the number of oscillations that occur. So the basic principle here is there is a water container here, and you have an escapement mechanism which makes sure that you're transferring the mechanical energy into the timekeeping element. And then you have a water wheel. It picks up the water, takes it up, fills it up into another chamber, and when it fills up, it tips over. When it tips over, it pushes the clock one point around, and then it goes up to on the top here, what you see here is a gong where when it moves over one unit, it hits it and creates a sound. And that's the way you're actually tracking time. It's a very complex process to keep track of time, but nonetheless very accurate because you're using a fixed amount of water at every step, and it is a chain and gear mechanism, so the rate at which it rotates is very fixed. And before we close this section, I just wanted to share with you this interesting book. It's called A Book of Knowledge of Mechanical Devices by Al-Jazari in 1200 AD. And what is fascinating about this is he had developed innumerable engineering designs purely as an artistic concept. So if you look at, for example, he has examples of a peacock water clock, a water pump, a water balance. All of these are very nicely designed engineering devices. I'm not sure if there's any evidence that any of these were actually built, but this book of mechanical devices was a very nice early book on good engineering design. That was published in 1200 AD. And so that sort of gives you a little bit of a flavor on how timekeeping pieces evolved over the ages, from very simple water-filling bowls to a much more complex mechanical system combined with a water escapement device to keep track of time.